Okay. So my name is Majid Tabal. I will be teaching you this course. So math. I said you to do first, right? Yeah, okay. Intermediate. Yeah, I guess you know the name. Calculus. And we're meeting from Monday till Thursday from 11 to 1:30, right? 11 to 1:25. Okay. Great. My email. McGill.ca or at mail. You can also reach out to me at mail.mcgill.ca. I'll be posting the office hours maybe this afternoon. I'll be giving you more details. Just let's see if this is clear. Is this too far? No, it's fine. It's fine. You can read, I guess. I'll have to write a bit bigger. Okay, great. So my office is in Burnside Hall 1018. I'll post all the details. Now the most important thing is the marking scheme. I will not write that down. 20% web work, 5% quiz, 25% midterm, 50% final. Or 20% web work, 5% quiz, and 75% final. The best of the two. You don't need to sign up for any marking scheme. Do you want me to write this down? Is that okay? That's okay, okay? I mean, I'll post the info. Do you want me to write this down? Okay, it's fine. Should I write this down? I'll just write this down. 20% web work, plus 5% quiz, and the quiz will be online, okay? So it's going to be a nice 25% for you to start out, okay? And a midterm during tutorial time. So I think the tutorials are 50 minutes here, right? Yeah, so it's going to be a midterm during the tutorial. So you're going to have 50% midterm. Sorry, 25% midterm during 50 minutes. The midterm, I can tell you from now, is just going to be a test that you practice your homework, you attended class. It's going to be fairly straightforward. Okay, so that's 25% for free. 20 on 25 will be very easy. 5% slightly more challenging, but fairly doable. Okay, and a 50% final, which is going to be tougher. And when I mean tougher, it means it's really tough. It's really tougher. It's not unfair, but it's tougher than the midterm. Okay? Final or 75% final, 20% homework, 5% quiz, plus 0% midterm. Okay, so I'll take the best of these two. Automatically, you don't need to sign up for anything. Midterm, there will be no makeup midterm. Okay? Should you miss it, your weight will go to the final. Okay? I encourage you to write the midterm. Sit and write it. I feel it's going to be fairly easy. Okay? Great. So let's get started now with the material. We're going to start with a recap on series. Series, we all know what series are, right? Very good. So we're going to start with a recap on series, and then continue with the material. Okay, great. So two things. I will post many resources online. So I'll post the recordings of maybe 3 or 4 times this course was taught. This or the other, the science version of this course. You have a Calculus 3 version of this course that's taught in science. So I'll post the recording of this one, and I'll post the recording of a previous version of 262. Okay, so in case there's something you don't understand, and you don't wish to ask me, although I invite you to ask me, and you don't want to ask me for you're afraid or whatever, you can just go there and view another way of explaining this stuff. Okay, but again, you can feel free to ask any question, and feel free to interrupt me during the lectures. Just please raise your hand, and I'll let you ask your question. Okay, great. So let's start now with series. We all know what series is. Yes. Is that right? Yeah, okay, so the textbooks. So there is no mandatory textbook, but I recommend you 2 textbooks. Because it's recorded. Oh, towards the blue book. Have you had textbook by, have you used textbook in calculus 1, 2? Towards? Which one? Whatever edition. Whatever edition you can get your hands on is good enough. Okay, any calculus textbook will work fine. Okay, I mean, I have a textbook by Adams and Essex. This is the textbook that was used like 12 years ago. Okay, so any calculus textbook that covers multivariate stuff is fine. Okay? Are we good here? Again, I assume full mastery of linear algebra and full mastery of calculus 2. As you will see, today we'll recap series and finish all the series you've done in calculus 2. Okay? So, okay, great. Let's get started. Any questions on the logistics or anything like that? Yes. Guys, yes. So there is something I emphasize a lot. When one student is talking, I appreciate that everybody remains silent. Okay? Yes. No, but I will let you know on Monday maybe. Is that good if I let you know about Monday? It's definitely not. It's gonna be at least in 2 weeks. At least in 2 weeks from Monday. Okay, it's gonna be in the tutorial time. And yeah. Okay, so I'll let you know as soon as possible. And there is a TA whom I have not contacted. It's my bad. So I will contact. Today there was no tutorial. I got an email from someone asking if there was a tutorial today. No, there was no tutorial. I'm sorry if this was not clear. But I start next week, obviously. I agree. Okay. So let's start the series. Okay, so just I'm gonna say a few words. Just they should seem familiar. Series, familiar? Geometric series. Just nod your head, okay? Just nod your head. Series, geometric series, alternating series, root test, ratio test, integral test. Yeah. Okay, great. Good. Limit comparison. Okay, great, awesome. So we can start fast, I guess. We can do it quick. So series. Recap. So let the end get sequence. As you realize, the pace will be very fast. Okay? So, and you will get used to it. Okay? Let the end get sequence. We say that. Yeah, I guess I jumped too quick, but that's okay. That the infinite series of n equal 1 to infinity a n converges to s. S a real number if the limit and then goes to infinity of Sn is equal to s, where Sn is sigma. Guys, yeah, k equal 1 to n is, right? We have seen this definition in calculus 2. Yeah? This is what it means for a series to converge, right? What is Sn called? Sn is, what do we call Sn? The n partial sum. Familiar? Yeah? Yes or no? Yeah, okay, great. Awesome. Now let's get back to geometric series. So what is the geometric series? Can anyone remind me? What's a geometric series? What form does it take? Yeah? Yeah, so okay. Oh, sorry. What is a geometric sequence? Sorry. What is a geometric sequence? What is a geometric sequence? You're giving me the answer, right? I mean, I asked what is it. Well, What is the definition of a geometric series? What is the end term of a geometric series?
A times R to the n.
A times R to the n. A sequence. AN. Is said to be geometric if AN plus 1 over AN is equal to R, the sum R and R. Of course, we'll assume that AN is different than 0, just for to take the ratio. Or you know what, we could do it another way. You could just say that AN plus 1 is equal to R times AN. Then I can write AN is A times R to the n minus 1 for n greater or equal to 1 and A is a real number. Okay, this is a geometric sequence, right? What is a geometric series? A geometric series is just the sum of the terms of a geometric sequence, right? Yes or no? Am I going fast? But this is stuff you have seen before, right? No? Yeah, okay, great. So if you have seen that, it's good to speed up a bit. Oh, no, wait. Oh, man, okay. This is locked here. So I guess I'll stick with these two boards. Geometric series has the form sum n equal 1 to plus infinity A times Rn minus 1. Okay, of course you can start somewhere else, right? You've seen all of this, right? You can start at n equal 4, for example, right? Yeah? All of this is clear. Great. So let us consider the sum of a geometric series. So what do you know from calculus 2? What is the sum? Converges or diverges? Or it depends?
Depends on.
It depends on R. Theorem? What is that equal to? This is just equal to A over 1 minus R, or diverges. What is the condition here? If what? If absolute value of R is less than 1, very good. And there, if the absolute value of R is bigger or equal to. Okay? Great. Awesome. We good here? Yes.
How does the formula change if you don't start from 1?
How does the formula change if what?
If you don't start from 1.
Sure, we can do examples. Okay? I don't want you to memorize formulas. Maybe if you can, just memorize this one. Okay? And then we'll see how to do that. Okay? So I won't repeat a lot of the calculus stuff. Okay, in calculus you've seen the ways how to restart and reshift and do things like that, right? How to start from n equal 3 and update the index here. No? You've seen this or not? Yeah. I'm pretty sure you've seen this because I've taught calculus before and you see this, of course. Great. I mean, we'll do examples as well, so we'll do many examples. So if R is different than 1, is the point, and AN is equal to A times from there, the class is being recorded. Okay. Okay, great. Let's do some examples. So in calculus 2, you spent a month on series, approximately a month. Right? So here we're going to spend this extra bit. Okay, we're going to try to cover everything that you have done. So let's do an example. What is this? Can you tell me if this converges or diverges? How do I write this? How can I? So what is 1/4? This is 1/2 to the 0, right? Plus 1/2 to the 1. Plus 1/2 squared. And so on. What is that? That's the sum from sigma k equal 1 to plus infinity 1/2 to the k minus 1. What is that equal to? Are we good with this? Yes? You guys should be very good at this now, okay? What is that equal to? 1 over 1 minus 1/2, which is 2. Is that right? Are we good? Great. Does this sum converge or diverge? Is it a geometric series? Is it a geometric series? Do I have a times r to the power of n, or n minus 1, or whatever?
Yeah.
Yeah. Does it converge or diverge? What is my r? My r is minus 1. So does this series converge or diverge? Diverge. Very good. Diverge. Very good. Awesome. So we've got a question that we're going to answer. Well, or let's do this. Does this sum converge or diverge? Does this series converge or diverge? Converge or diverge? How do I find, does it converge or does it diverge? Converge. How do I find the limits of the, is that a geometric series?
Yeah.
How do I find it? How do I find the value of this series, of this sum? Yeah? Don't hesitate to
Take the unknown.
take 1/3 out so that I can apply my formula. Okay, let's write this one here. Let me write this way. Okay, so I can take a 1/3 out so that I can apply my formula, right? I mean, you can do it many ways, but if you want to apply the formula, I can write it this way. Isn't that right?
Yeah.
Yeah? What is that equal to? This is just 1/3. I can take the 1/3 out, right? I turn this into a geometric series? If I could turn it into a geometric series.
Negative 5 over 8 to the 4. all
Exactly.
together.
Very good. It's just the sum of n equal to infinity, negative 5 over 8 to the 4 to the power n. Is this number, is this r, is it smaller than 1 in absolute values or not? In absolute, the absolute value of minus 5 over 8 to the 4, is it smaller than 1? Strictly smaller than 1, right?
Yeah.
Minus 5 over 60, well, minus 5 over 64 squared, right? Still, you don't need to compute it, right? You can spot it. Yeah? Now, can I apply my formula here? Or I should do something first?
Should make it the -1.
Pardon me?
Should make it the -1.
You mean, oh, you mean here?
Yeah.
Okay. But where do I need to start?
You index shift, and then
Yeah. So you said something?
do you need to index shift?
Exactly. You need to kind of change the indexing. I assume you've seen that, right? Yeah? Have you? Have you seen this? Have you seen how to find the sum before? Yeah. So how did you do it? You wrote all the terms down and you factored something out? Is that how you did it? Okay, so I mean, you have this formula. It is r is less than 1. Okay. In absolute value. Now notice, where does this sum start? This n minus 1, where does it start? N. If n is 1, what is the first value of n minus 1? 0. Now, what you really want to do is that have this value here be 0 as the first value of n. Right? Now, how do you make this thing to have value 0 when n is 2? Minus 2. Great. Minus 5 over 8 to the 4 times n minus 2. Now, is this correct or I missed something? Is this mathematically correct?
No,
No. So what do I have to multiply by?
that's squared.
That's squared. Very good. Wait a minute. That I can take out. Now, when you can shift the indices, you can shift the index, start at n equal 1, say, right? Yeah? But what is this sum, the series, what is it equal to? I can just apply my formula here, right? Do you see that or not? Do you see that? That I can apply my formula? So your formula, what does it say? It says that, I don't want to write here at the same time, but this is a bit. Your formula says it's 1 plus r squared dot is equal to 1 over 1 minus r if r is less than 1. Agree or not? This is what your formula shows. Right? Okay, so I usually get this wrong. I usually rederive it every time. But so far I think it's good. But this is what your formula says. Now, does this thing apply here? What is the first term of your sum? Let this be r. R to the 0 is 1. R, because it starts at 2. If n is equal to 3, r to the 3 minus 2 is r. Right? So this is just minus 5 over 8 to the 4 squared times 1 over 1 plus 5 over 8. Okay? We good? the series of AN converges, what can I say about AN? If sum n equal 1 to infinity to AN converges, what can you say about AN? What can you say about the limit of AN? Someone say something? Yeah, exactly. Hero? If sum n equal 1 to AN converges, then what? Then the limit as n equal to infinity of AN is equal to 0. Is the converse true? If the limit of AN goes to 0, does that necessarily imply that the series of AN converge? What's a nice example that you all have seen?
Harmonic series.
Pardon me?
The harmonic series.
The harmonic series. What is AN in the harmonic series? What is AN?
1 over n.
1 over n, right? The converse is not true. It's not true. So we know the limit of n goes to infinity of 1 over n is 0, but right? We've seen this in calculus 2, right? Great. Let's do an example or two. Let's do an example. Someone gives me a number. Throw a number.
4.
4. Someone else throw a number. 6. So someone said 6 and someone said 3. What was the other one? 4. And I also need x. Does it converge? Does this series converge or diverge? Does this series converge or diverge?
Diverge.
Diverge. Why?
The
And you person who haven't spoken today?
limit is not 0.
The limit of what term is not 0? Of the 6n plus 3 over?
Yeah, it's not.
What is it? What is the limit?
It's 3 over 2.
3 over 2. Very good. Diverges in the limit and then goes to infinity of 6n plus 3 over 4n plus 10 is equal to 6 over 4, which is 3 over 2. Okay? Agreed? One more? We can find, does this series converge or diverge? Converge or diverge? Does it converge or does it diverge?
Diverge.
Diverge. Why? The limit of minus 1 to the n is non-zero. Does it have a limit? Does minus 1 to the n have a limit? Exactly. So, since minus 1 to the n diverge. Okay? So minus 1 to the n, you know that it doesn't have a limit, right? The sequence minus 1 to the n does not have a limit. Or what's another way of doing this?
Geometric.
Geometric series, right? This is a geometric series with r is equal to r is equal to minus 1. Okay? Great. Awesome. So it diverges. Okay. So far so good? Awesome. Again, I if in case if you are not very comfortable with this, I invite you to revisit your Calculus 2 material. Okay? Have you seen Taylor series in Calculus 2? No Taylor series? Zero.
Sure.
Okay. Great. Power series, like a power you've seen power series?
We didn't.
In the fall semester, we saw power series. In the winter, they didn't.
Yeah.
Okay. I see. Okay, that's great. Okay, everyone. Theorem. Well, I mean, let's A. So do you want the tutorials to cover series, to recap the series of Calculus 2? I can ask the TA to do that.
Yes.
I can ask them to do that. Let's have tutorials to recap on series, because this is just recap here. Okay? Yes.
Why does that not have a limit?
-1 to the end. Hi, have you seen that or not? Have you seen why it doesn't have a limit? You haven't seen that. Okay. Yeah, that might be a bit harder to I mean, you could do it technically. I mean, great. So suppose it has a limit. Okay, so suppose an has a limit. Suppose an has limit L. What is the limit as n goes to infinity of an plus 1? If the limit of an is L, what is the limit of an plus 1 as n goes to infinity?
L plus.
L, right?
Okay.
You agree? If n is very big, and this is L, then n plus 1 is also very big and goes to L, right? So what's the limit of an plus 1 minus an if an has limit L?
0.
0. Now, in that case, what is an plus 1 minus?
Oh, okay.
Well, what is the limit? So the limit of the absolute value of this is 0, right?
But there's 2.
Yeah. Right? So what is the difference of an plus 1 minus an? Okay. Oh, wait a second. Yeah, okay. Yeah. That's one way. Another way is with subsequences. Right? Have you seen no, I don't think you see subsequences. C at the end, just C, right? If C is a real number. Okay, this you have seen in calculus too, right? You have seen that. So let's continue. Okay, I think I'm going a bit fast, but that's okay. That's okay. We'll slow down later. It's better to go fast in the stuff you have seen than go fast at the end where it's a new material. So I'll go very fast at the beginning and stuff that you have seen, right? So let's apply this example. Okay, by the way, I don't know, when is the add job deadline for this course? When is it? Monday? Next week. Okay, so technically I'm not allowed to give you a homework due before the add job deadline. Okay, but I can assign homework, and they will be due just like 1 minute after the add job deadline. Okay, so let's say the add job deadline is 12 a.m. They will be due at 12:01 a.m. Okay, so you have to expect a lot of workworks to make you practice this. Okay, so you should expect about a workwork for Monday. So I release a workwork on Monday, and it will be due on Thursday. And I will release a workwork on Thursday, it will be due Monday. So every workwork is going to be about like 30 to 40 questions. Okay? Again, this is a summer course, you have only 1 month. And it's worth, and I will put a quiz, right? I have to put an online quiz as well. I mean, it's 25%, right? I don't know why you're upset. It's 25% that you're taking home for free. And I'll make sure that if you have to take 25% for free, more or less, I guess, you have to work hard for it. Okay? 25% at home, I mean, I think it's a good deal. I think it's a good deal. Unless you want to wait to the final, I don't mind. Reduce the work and put more weight on the final. So you'll have a lot of questions and a lot of practice. And then, the more you practice, the better you'll get. Practice makes perfect, yes. Yeah, that's a good point. So, I'm thinking of non-quiz workworks will have limited trials. If I decide to put the online quiz as workworks, right? If I put it on the workwork platform, then they will have limited trials. The quiz, but regular workworks as much as you want. Okay? I don't know, did you guys prefer like limited trials? Okay. You prefer that? It's easy for me. I mean, to be honest, my average is like five trials, especially if you have numbers to plug in. If you have a final answer, you can put it on a calculator. But I mean, okay, so maybe let's get this done at the beginning. No calculators allowed. Okay? So all the computations you should be able to do them in your head. I think you're used to this in your math classes, right? You don't have the right for a calculator. No group sheet whatsoever. You'll have to memorize everything by heart or redirect them. I prefer that you redirect them, but some of you prefer memorization. I'm fine by either of these choices. But it's if you memorize it wrong, too bad. Okay? Like it's not my fault. Okay? So I prefer that you know how to redirect things. Okay. Great. So how do I find this series? 2/3. So what is that? It's 1/2/3, which is 3/2, plus 1/1/3, which is, what is 1/1/3?
3.
3. 3/2 is, so how do you put on the same denominator? What do you get? Immediately 3/2 plus 6/2 is 9/2. Did I get this right? I don't know. I think I did. I don't have the answer. Is that right? Yes. Did I mess it up?
Why we don't need to use the -1?
Oh, shoot. You see? I said that. Very good. Very good. Someone is following. No, I'm kidding. I just made a mistake. So, right? That's good. That's good. That's good. That's really good. Don't memorize things, because if you memorize things, you will fall. And I fell. It's a pretty bad fall, actually. Right? So it's 2. And now you get your signs. Plus. Okay. And that's a quick trick. How you do this fraction? Multiply by 3 immediately. Don't reverse everything. So it's 1/3 minus 1, so it's 1/2, right? Is that right? Did I mess this up again or not? No. So plus 4/3 minus what? 3 minus 2 is 1. Plus 4. So it's 9/3. Is that right? Is that right now? Very good. You see, when you memorize things, it's easy to do a mistake. Okay? It's very easy to do a mistake. And on multiple choice, so you'll have a multiple choice section on the final. This is the plan at least. Okay? And I'm not very nice on multiple choice questions. So usually on multiple choice questions, what I will do is that I will do the question myself and look at the possible mistakes that you can make and put these as options. Okay? This is the final exam multiple choice. And I think it's this in order math classes, right? Multiple choices are tricky, right? How many can say, oh, I got the right answer, and it turns out to be wrong at the end, right? Happens before. You had multiple choice, of course, in calculus, right, or linear algebra, right? Yeah, because, okay, great.
Sorry.
Pardon me.
What if instead of 2 we have like 4 or something that diverges?
Then oh, you mean up?
Yeah.
Very good question. Very good question. What if I had here 4? Very good question. So what if I had does this converge or does it diverge? Diverge. Why does it diverge? Let's give one. Well,
You can split it and get geometric.
I'll do it here. I'll do it this way. Sure, I could get geometric. I could split it. Everybody, I could split this sum. Now the first part diverges. Why is that? This one converges. Agree or not? The first term converges. Yes or no? Yes. The second term diverges. Agree? So far easy, right? The first term converges, the second term diverges. Now if the sum converges, converges. What can I say about this difference between this one and this one? The difference of two converging things is convergence, right? And convergence. Now, what is this difference? This difference is just this one. We see this? You've seen this before? Yeah? Yeah? Contradiction. Okay. Okay. Great. Is this argument clear or not? Are we good? Folks, are we good with this one? Yeah? Anybody wants me to repeat it? Don't hesitate to ask. Okay, we're good then. Okay, great. Now, much of your Cal2 course at the end was devoted to study series with positive terms, right? Right? Sum of an where an is positive. Okay? So now we'll do that. We'll go over. So what are the main tests that you have seen? 8? Okay. Well, I don't know. I don't have the mind, but so what are the tests that you have seen? State them. So someone give me a test. Integral test, very good.
Limit.
Ratio test. What is it? Say again.
Limit comparison test.
So it's this one where you take an over bn and you look at the limits, right? Yeah. Okay. What as well? Root test. So what is the root test? An to the 1 over n, right? What as well?
What is divergence?
Oh, you take the limit. I don't know what it's called, but you know, I don't know what it's called. So you call it divergence test. Limit of an. Okay, divergence test. Root test. Yeah. So you take an. Guys, please. An the 1 over n. If an is positive, and you look at the limit. You take the ratio test. An plus 1 over an. I mean, you know, you can generalize this to absolute values, right? So you've seen these, right? And then you take limit comparison. Yeah, I think that, I don't know if I forgot one, but, or comparison, right? Direct comparison, right? You've seen all of these, right?
Yes.
And I think that's pretty much it. And then you have the alternating series, right?
And the telescoping one.
Yeah, also telescopic series like an plus 1 minus an. So we'll do some examples on this. Yeah, but do you have a test for this one, or you just write it down? You just write it down, right? You don't have a test. Okay. So we'll go over this. Okay, I think it should be very familiar. That's why we're going a bit fast. Great. So let's start with the test you like a lot, the integral test. Okay, you like the integral test a lot? Yeah. So anyone can help me with the integral test? Do you guys remember what the integral test is? We all took calculus 2, right? If you did not take calculus 2 again, you should reconsider this class. I don't know if they're like they check your prereqs, but if they don't check your prereqs, if you haven't taken calculus 2, it may go very, very badly. Maybe very like okay, so you must be very comfortable with calculus 2. Okay, so what does the integral test state?
when you have a series and then you turn it into an improper integral, and then we see if the improper integral converges,
Okay.
then the series converges.
Sure, very good, but just like that, I can throw any series and then any improper integral. That's very good. That's a very good start. Very good. Thank you very much for initiating because people are raising their hands. Yes. Positive, decreasing, and so a sequence is continuous or something else is continuous. So very good, very good, very good. No, that's very good. It's a function. What function? So I have f of x, and I have a sequence a n is equal to f of n. F is decreasing, positive. So I can compare the series and the integral. And what's most importantly, other than decreasing and continuous. We've seen this?
Yes.
Yeah. Okay. So let n be an integer. Integral n. Let n be an integer, be a positive integer. Let n be a continuous. Positive. And decreasing function on n infinity. Yeah, I don't know. Have you seen it in this form or you've seen it from n equal 1? Have you seen it n or just 1? 1? Okay, well, but it's not a big deal. But, okay, so it's not a big deal. Of course, if it's decreasing positive from 10 to infinity, that's still okay, right? The series, when you have a series, you don't care about the first few terms, right? You've seen this, I guess. Yeah? Yes or no? You don't care about the first few terms. You just care about the tail, right? Okay. So let that be a continuous positive and decreasing function on 1 to infinity. Then, I will not prove this, but I think you proved this in last term. Then, and let a n be equal to f of n. Then, sigma n equal 1 is a n both converge or both diverge. Well, then yeah, grammatically is correct, right? Then both converge or both diverge. Okay, and I think you proved that. You saw the proof of this one, right? How do you prove this one? Do you remember? You just an area under the curve argument, right? You look at the top and the bottom, right? Okay, I'll let you revisit the proof of this one. Of course, you don't have to. Yes.
Resulting violence?
Not the one that would emphasize. Okay, so this one I'm not emphasizing it. You've seen the proof in class 2 actually, didn't you? You did an area under the curve. You bound the up and the bottom, right? And then you squeeze or something like that. You remember this? Yeah. Okay. So let's do an example. why is that? Why does it diverge? How can you prove it using the integral test? So I have to check, is 1 over n positive? So an here, 1 over n is f of n, where f of x is equal to what? 1 over x, right? Is 1 over x decreasing going 1 to infinity?
Yeah.
Yeah. Is it positive?
Yeah.
Is it continuous?
Yeah.
Great. So f is continuous, decreasing, and positive on 1 to infinity. Now, what is the integral of 1 to infinity 1 over x dx? Does it converge or does it diverge?
Divergent.
Does it? It diverges, right? What's an antiderivative of 1 over x on 1 to infinity? It's ln of x, right? Ln of x from infinity to 1, what is that? It's ln of infinity minus ln of 1, which is infinity, right? Yes or no? You've seen this? Do I need to write this, or that's okay if I just say diverges? Do I need to write the ln x part? Let's do that. Ln x from infinity to 1, which is infinity, so diverges. So the harmonic series diverges. Well, so I mean, there's another way to show this, right? But anyways. Okay, what are other series that I can use, for which I can use the integral test? Yeah. Ln x over. Okay, sure. Easier. I just want something a bit easier. A bit easier. That generalizes 1 over n. So if I take 1 over n squared, can I use the integral test?
Yeah.
What did you call these? Say? Yeah, say. P series, right? Have we heard this? P series? Great. So P series. P series. So P is strictly bigger than 0. One over n to the p. What is the result on this one? What is the result that you have seen? Convergence. If p is bigger than 1, right? And divergence, I mean, you've seen it with p positive, where you allow p to be negative as well. I mean, I'll assume p is positive, okay? If p is negative, then it's obvious, right? You see that? If p is negative, then this thing terms goes to infinity, okay? Convergence of p is equal to 1, and divergence and how do I prove that? By how do I prove this? Integral test, right? Should I prove it or should I do it again? Do you want me to do this again or not? We're good. If you want to do this again, just nod your head and I will just make a sign in your, if you don't want to speak up. Yeah, so I'll do it again, okay? So 1 over n to the p is equal to f of n, where f of x for x belongs to 1 to infinity. Okay, so if p is positive, here p is positive, right? I pick p to be positive. Okay, p is positive. If p is positive, what can I say about x to the p? Is it increasing or decreasing? X to the p. X to the p is positive and increasing, right? So 1 over x to the p is positive and decreasing. And is f continuous? Of course, right? It's 1 over x to the p, and this x to the p never vanishes on 1 to infinity, right? F is continuous, positive, and Anybody who was in the French system here? Yeah, so you use this, right? You don't, okay? So, great. Yeah, so the French system doesn't use this. I have to get used to it, I guess. Maybe I should have, but anyways. Okay, now it's clear, now it's good. Okay, f is continuous, positive and decreasing. Now what is A? What is the integral? 1 over x to the p. How do I integrate that? Don't forget your dx's. How do I integrate that? If p is different than 1. Okay, so let p be different than 1. Right, because we established that if p is equal to 1, this is this diverges. How do I do that? How do I integrate this?
X to the negative p and then
X to the negative, so okay, so you want to do it this way, so yeah, very good, you can do it. Yeah? So what is that? This is just, what is the antiderivative of this? It's this one, right? Right? So p is different than 1, of course. Now, if p is bigger than 1, what is x to the minus p plus 1 if x equal infinity? What is this limit? 0, right? Yeah. Say p is bigger than 1, so minus p plus 1 is negative. X to a negative power when x goes to infinity is 0. 0. So what is that? 0. And if x is equal to 1, what do you get? If x is equal to 1, here. This is 0. Then minus, plug in x equal to 1, what do you get? 1 over 1 minus p, right? There, does that make sense? So if p, oh wait a second, here, okay, so if p is bigger than 1, if p is bigger than 1, then that's what you get, right? Does that make sense or not? Is this number positive? 1 minus p is negative. Minus 1 minus p is positive. Okay, so it's a good check. Now if p is less than 1, if p is between 0, if p is between 0 and 1, what is this limit? Where is it? If p is between 0 and 1, oops. Still x to the minus p plus 1 over minus p plus 1 from infinity to 1. What is that? Say p is 1 half, for example. What is x to the 1 half at infinity? X to the 1 half at infinity, what is that? P is smaller than 1, so 1 minus p is positive. So x to a positive power at x equal infinity, what do you get? Infinity, right? Infinity. So, my integral then converges. If p is bigger than 1, okay. Again, please, if you're not comfortable with this material, please review your notes from calculus 2. Okay. Now before we try, is this is n squared e to the minus n cubed decreasing? Do you know this? Do you know if it's decreasing?
Yeah.
You expect it to be decreasing, right? Because an exponential will kill the polynomial, right? The negative exponential here is way stronger than the polynomial. You see that?
Yeah.
Yeah, and does it converge to zero? By the way, this is the first thing you should see. Does this converge to zero? N squared e to the minus n cubed, does it converge to zero?
Yes.
What do you think? So how do you check if this converges to zero? So I mean, the limit rules, what does it say? This n squared is infinity, right? And this e to the minus n cubed is zero. Infinity times zero is what? Indeterminate. So you cannot do anything. But what can you do? You still can do something, right? So you take n squared over e to the n cubed. What form do you get here? Infinity over infinity, right? I mean, you just have to put the x's, right? You have to put x squared over dx cubed. Great, infinity over infinity. What can you use here? We have a friend that we call every time we have a, yeah, Hopital rule. Differentiate once. You have 2x over that thing, right? The over derivative of that thing. It will still be infinity over infinity, right?
Okay.
2x derivative of x ex cubed, what is that? It's 3x squared times ex cubed. Infinity over infinity. Oh, yeah, but you can do that. Or you can cancel the x's, right? If you cancel the x's, so your friend was referring to 2x and then 3x squared over ex cubed. Now you can still do L'Hopital here, infinity, infinity. Or you could cancel this x, which is way smarter. And then this goes to zero. Okay? But you don't need to do that. Okay? I mean, just do that check that you can do. That this converges to zero. So the limit of this term is zero. So you have to think about something else. Now does it integrate nicely? Does this thing integrate? Does 1 to infinity x cubed e to the x squared e to the minus x cubed, does it have a nice integral? It does, right? Technically. So that's x squared e to the minus x cubed. So what is that? This is the e to the minus x cubed over minus 3, right? And then the derivative of this one is this one, right? Yes or no? Yeah? Plus infinity, 1. Well, e to the minus infinity is 0. And then e to the minus, well, so it's e to the minus 1 over minus 3. So this is this. And I'm done by the integral test, right? Am I done or not? Am I done? Am I done?
You say the series converges.
The series converges, right?
Yeah.
Because this integral converges. Am I done or not?
Yeah.
Did I miss something or not? Is that? I definitely missed big parts of that. Right? To apply the integral test, what do I need?
Continuous.
I need f to be continuous, decreasing, and positive. N squared e to the minus n cubed is f of n, where f of x is x squared e to the minus x cubed. Now, how do I do that? How do I check? Is it positive? Of course. F is positive and continuous on 1 plus infinity. And I'll write this one and continue. Now, is it decreasing? How can I check if it's decreasing or not in that case? What can I do? Take the derivative, right? So you can do it many ways. But I prefer to just take f of x is x squared over e to the x cubed. What is f prime of x, u over v, so u prime v minus v prime, u over v squared. Okay? What is that? Let's factor out into the x cubed first. So I can factor into the x cubed. And I can factor, let's see, I can factor an x out. X into the x cubed, so I have 2 minus 3
x three x two.
3x cubed, very good, over, okay, right? Now is this derivative positive or negative on 1 to infinity? Notice that all the terms, if x is bigger than 1, if x is bigger than 1, this is positive, and this is positive. All you have to do is this one. You have to check. What is the sign of this one? So if x is bigger than 1, what can you say about 3x cubed? It's bigger than 3, right? So it's bigger than 2, right? So this is negative. If x is bigger than 1. X is bigger than 1. Doesn't really matter. So f is decreasing on 1 to infinity. Great. So can I apply the integral test?
Yeah.
So now I can apply the integral test because f is continuous, in fact differentiable, positive and decreasing. Agree or not? Everybody? Yes, good or no? Yeah? Great. Now, let's apply the integral test. So what did I have? X squared e to the minus x cubed dx. So I'll then integrate that. It's just e to the minus x cubed over minus 3, right? Differentiate, you get minus 3x squared over minus 3, so you get x squared. Very good. From infinity to 1, plus. So 0, yeah, e to the minus infinity is 0, and then e to the minus 1 over 3 converges, hence very good. Right? Any questions? Questions? Yes, sir.
Is there any relation between the value, the integral?
Yes, there is. There is.
They converge to the same thing?
No, there, you can bound them. I mean, if you're interested, we can discuss that. Yeah, we can do that. I mean, I have something ready for it, but I prefer to postpone it to a later date. So, have you seen the connection? Have you bounded this term? You haven't bounded this term. Okay, that's okay. We'll bound it later, I guess. We'll bound it later. I mean, did you prove this result in class minus 2? Did you prove it?
Yeah.
The proof gives you the bound, actually. Okay, the proofs gives you errors, basically. Okay, you can bound the error terms with the proof. Anyways, if you have not seen that or if you don't remember it, that's okay. We'll come back to this later. Okay? Great. This is clear. So your friend mentioned you wanted to do an example, ln x over x. Let's try and do this one. Ln n over n. So I guess you know that the integral test, you have to try the integral test, right? So does sum n equal 1 and ln n over n converge or diverge? Okay, let's do that. I mean, the errors, by the way, I don't wanna, I thought of postponing it because you may need calculators for that. So I mean, if you need calculators, probably you won't need. Okay, so does this series converge or diverge? What's the first thing to check? The limit of the the term. So you have ln n over n. Does this go to 0 or not? It does go to 0, right? Think about it l'hôpital. So ln x over x as x goes to infinity, infinity over infinity, indeterminate form, l'hôpital, you get 1 over x over 1, which goes to 0. Great. Awesome. Now, is this, you're kind of stuck. Now, does ln x over x integrate easily? It does integrate easily. Why is that? Because ln x over x, an x derivative of ln x over x, the x, what is that equal to? I'm here like, just the way one could think when you tackle a problem. Of course, you don't have to show me all this work. Well, I mean, you do when you write the answer, but you don't have to tell me how you got there. You just have to give me the answer. Well, not the answer with justification, but you don't have to tell me why you thought of using the integral test, right? So ln x over x. So what's an x derivative? What's the derivative of ln x? It's 1 over x, right? So you have ln x times 1 over x. So it's u times u prime. What's the derivative of u times u prime? It's u squared over 2, right? And then the derivative of ln x over x is ln x squared over 2 plus c. Okay, so I can integrate that. And the integral of that from 1 to infinity, does it diverge or converge? Ln infinity is, ln infinity squared is infinity, minus ln of 1, which is 0. So this integral diverges. So if I can apply the integral test, my theory diverges. Okay? So this might be a good way to go. So the integral test might be a good way to go. So what do I have to check? What do I have to do? Continuous, positive, and decreasing. So let f of x, so ln n over n is f of n, where f of x is equal to ln x over x, where x, and you can define on a bigger interval, but you don't really care what happens on a bigger interval. We care about 1 to infinity. Okay, is that continuous?
Yeah.
F is clearly continuous. Now is f positive? F is positive. You agree? Because if x is bigger than 1, then ln x is bigger than 1, right? Bigger or equal to 1, it doesn't matter. Right? Bigger or equal to 0 doesn't, the first term of this sum is 0. You see that? If you plug in n equal 1 here, you get ln 1 over 1, so which is 0. So it doesn't matter. All you have to look at this one. Great. Is f positive? F is positive. F of x is bigger or equal to 0, where x bigger or equal to 1, because x is bigger or equal to 0, x is strictly bigger than 0, and ln x is bigger or equal to 0 if x is bigger than 1. Great. Is f continuous? And continuous, of course. Ln is continuous, x is continuous, and they don't, and x does not vanish. So ln x over x is continuous. Great. Now what do I have to check now? That is decreasing. How do I check it's decreasing? Something like that. How do you do that? The derivative, right? So what is f prime of x? Can anyone help me? Any help? F prime of x is equal to what? F prime of x, the derivative of ln of x is 1 over x, right? Times x. Minus what the derivative of x is 1. Over what? Over x squared. So you get 1 minus ln x over x squared. Agree? Did I mess it up? Or it's good? It's good? Great. Now, what can you say about this? Increasing or is it positive or negative? Or it depends? If x is very big, what can you say? If x is bigger than 75 million, what can you say about this derivative? It's negative, right? In fact, if x is bigger than 3, this derivative is negative. Agree or not? You guys see this? Do we see it? Yeah? 100%. Yeah or no? No, we don't see that. Okay. Let's go back to class 1. how do you find the critical point of this? The critical points, or like, how do you find the critical numbers? You solve f prime of x is equal to 0, right? When is this equal to 0? If x is equal to
1.
e, right?
Yeah.
If x is equal to e, f prime of x, you do something like that, right? X is equal to e, f prime of x is 0, right? Or no? And if x is bigger than e, what can you say about f prime of x? Negative. And if x is between 0 and e, what can you say about the derivative? Positive. Agree or not? Well, I mean, I don't know. This way? Yeah. Anyways, doesn't matter how you do it, but you guys got the points, right? If x is bigger than e, then this is negative, right? It's negative if x is bigger than e. Now, if I have a series, do I really care about the first few terms? No. So if f is decreasing on some interval, say 5 to infinity, I can still apply the integral test, right? This is the original version I had, but you've seen that, right? F is eventually decreasing, we called it, right? Something like that? Yeah? Yes or no? Yeah. You called it like that or no? F is eventually decreasing, like it's decreasing on 3 to infinity, say, or 10 to infinity. Okay? So if f is decreasing, so f is decreasing on e to infinity. I can still put on 3 to infinity, right? That's still true. I can put on 10 to infinity, right? Yes.
Can we do the integral test if it's negative and increasing?
If it's negative,
And increasing.
well, I mean, switch them, put minuses on both sides. It can work, right? It's negative and increasing.
So you can
So
do it.
take minus, it will be positive and decrease.
Yeah, so you can.
Yeah, I mean, but you can just flip the minus, right? You can, yeah. Okay, and so what can I use? I can use the integral test. So integrate wherever you want. Where do you want to start? You want to start at 1? You can start at 1. That's okay. That's fine, because it doesn't matter. If you want to start at 3, we could start at 3. What do you prefer? Where do you prefer to start? 3? 3. Sure. You'll see that the answer doesn't change. How do I integrate ln x over x? What do you do? Ln x, what's the derivative of ln x? 1 over x. So you have ln x times the derivative of ln x. So you have u times u prime. What's the derivative of u times u prime? It's u squared over 2, right? From infinity to 3. What is that? Ln of infinity squared is infinity. Minus ln of 3 squared over 2, still infinity, right? Hence, ln n over n. Okay? So easy derivatives like that you can do without doing u sub. You can just say you can do it just by looking at it, and then you can do it. Okay? You don't have to say u is ln x and du is yes sir.
So just to clarify, like the function just has to eventually decrease.
Exactly.
No matter if
Yes.
it's increasing.
Yeah, you have seen this in Calc 1, in Calc 2.
I took that like 2 semesters ago.
Okay, okay. So but it has to be eventually decreased. Yeah, exactly. Series, you don't care about the first 3 terms. They can be whatever you want. What matters is the end.
And also it doesn't matter what you do the lower bound.
As long as it's because the integral, say you start at 1. The integral from 1 to 3 is finite, so it won't change anything. Right? You see that?
Yeah, yeah.
Okay. Any questions? Oh, we still have an hour. We still have 50 minutes. Well, what? How much we still have? 50 minutes? Yeah, okay, that's good. That's good. Is it fast? It's fast? It's good? Who finds it fast? Great. Okay. That's good. Because it's stuff you must have seen, right? You have seen all of this. Okay, let's do comparison and limit comparison. Yeah, so I will make sure you practice this series business a lot. Okay? I will give you like many practice questions on series so that I make sure that you're ready to start. Okay. I'll talk about two tests. Comparison tests and limit comparison. By the way, have you seen conditional and absolute convergence or not? Okay, that's good. That's good. Okay. I'm tempted to do something new, but let's. Okay, comparison. Let AN in BN be sequences such that AN is less or equal to BN. So all the terms are non-negative. Then what? Then if sigma n equal 1 to infinity Bn converges, then converges, right? You have seen this. And the next one, so if the bigger one converges, the series of the bigger one converges, then the AN converges, right? The series of AN converges. And if the series of AN converges, if the series of AN diverges, what can you say about BN? The series of BN diverges, right? Okay. Okay, now this test I will try not to, because this test is a bit not very easy to apply, right? I'm not saying it's impossible or it's hard, but you always have to show this one first. And this may not be very easy. We'll try to see a work around this. Okay? But anyways, it's good to know. It's good to know. Sigma dn in practice, in theory, you use this a lot. In the theory actually like you can use this a lot, but in practice, for example, if you have the actual numbers, sometimes it's but anyways, it's not if sigma AN diverges, okay. Let's take a small example. Does this converge or diverge? This is obvious, right? Yeah. Does it converge or does it diverge? okay, but you can say it's eventually strictly positive, or an could be negative, an could be 0, for example, but not the n. But I'll just write it strictly positive. Strictly positive. Well, we need some terms in negative. Sequences, eventually, basically, such that the limit, and then goes to infinity, of an over bn is equal to L where L is between 0 and infinity. So L cannot be infinity. Then what can you say about this series? What can you say? Did you see it in this version? There are many versions. Then both of them converge or both of them diverge, right? Did you see this? Did you see it in this way?
Yes.
Is that this way you see? L is between 0 and infinity, so L must be a finite, strictly positive number. Then both converge or both diverge. Okay? Is that how you've seen it? You can make it conversation. Let's undo that. You may not have seen that. I guess that's the one you'll need. Okay, let's do an example. We'll do an easy one. First we'll do an easy one, and then we'll move to a harder one. Okay? Okay, so let's look at this one. Does the series converge or diverge? What is the term that will eat everything? N squared is the term that will dominate, right? So this series, you expect it to behave like what series? 1 over n squared. Now as a series 1 over n squared, does it converge or not? Yeah. So what do you expect the series to converge? By what test? Limit comparison, right? So let an is 1 over n squared. Is it clear that an is positive or not? Is it clear that this number is never 0? If it's not, just convince yourself that you can write it this way. Right? N minus 1 squared plus 1 greater than 0. And let Bn be 1 over n squared. What's the limit of an over Bn? Bn is also strictly positive. What's this limit? What is should be an? This one. So I'll just do the math quickly. So n squared goes on top. And this one goes on the bottom. What is this limit? Immediately by just looking at it. Just look at it. What do you get? 1. Very good. Is it between 0 and infinity strictly? Yeah, so what can you apply? The limit comparison test, right? By limit comparison test. Since the next one. And this may be a bit. It's a big. This is a bit harder. But you have seen examples like that, I assume, right? You have done things like that. Now, does this series converge or diverge? Want to compare it? Yes, sir.
Divergence.
Divergence. Very good. Any reason?
Can you assume that small theta, tan theta is equal to theta? So you just take 1 over n squared to 1 over n.
Very good. That's right. Right? Is that clear or is it clear? So you've seen a limit. Sine x over x when x goes to 0. What is this limit? 1. Right? Now if x goes to 0, you can assume that your x is really 1 over n, right? You agree? Now, while you say that tangent, you have sine over cosine. Where did the cosine go? What's cosine of 1 over n if n is large? 1. So the cosine doesn't matter. Right? You see that? So what is the thing you want to compare to? You want to compare tangent 1 over n to 1 over n. Now, one thing we should take into account is tangent 1 over n positive if or not. One over n, in what quadrant does it lie? Everybody? 1 over n. So you have the first quadrant from 0 to pi over 2. Pi is 314 something, right? 314, 15, 92, something. Divide pi by 2, what do you get? 1 point. So 1 over n, in what quadrant does it lie? In the first quadrant, right? So tangent 1 over n is positive, right? So 1 over n belongs to 0 pi by 2. So tangent 1 over n is positive. Right? Now, the limit as n goes to infinity. We said that we want to compare it with 1 over n. Of course, 1 over n is positive. Agree with this. Tangent 1 over n over 1 over n. What is that equal to? Well, sine 1 over n. Cosine 1 over n. Times 1 over n. Right or no? Yes? Cosine 1 over n if n goes to infinity, what is that equal to? 1. Does it matter? No. Sine 1 over n over 1 over n as n goes to infinity. You can expect it to be the same thing as sine x over x as x approaches 0, right? What is that? Sine x over x as x approaches 0? 1. You want to write more? That's fine. That's fine, right?
Yeah.
Is that okay? This is calculus law. Since limit as x goes to 0 you want me to post a practice final on calculus 2 just to know what I expect from you to be, like, what I expect from you? Is that okay? So I'll post a final from calc 2, and you should be able to more or less do it, okay? Especially the series part. And integration, that's okay. I mean, you still have to know how to integrate, but this course is not about, like, integrate secant cube, okay? You won't have things like that. I mean, I don't even know, I can't remember how to do this, but no, I'm kidding, but, okay? But this is not the goal of integration, more series part. Okay, so I can post, like, previous finals that are online, just to be sure that you know how to do the series stuff, because it's very crucial that you know how to do that, okay? Okay, we still have some time. We still have some time. That's nice, actually. Okay. So I'll do the ratio there for positive sequences. Voilà. Okay, great. So this was an important part of the course. Well, not for this one, it's still an important part for this course, but this was an important part from the previous 141. Does anyone have a question on this? On the parts that we have done? Any questions, suggestions, something you want me to go over again? Yes.
Okay, what identities do we have to memorize?
What do you mean by that?
Identities. The
Trig?
identity.
All of them. Okay, so you might need all of them. You might need all of them. Yeah, you might need all of them. But I mean, you don't have to memorize these, right? Right, you have to memorize 2 or 3 and then you derive the others. Is that how you do it, or you just memorize? Yeah, you have to know 2 or 3. Cos squared plus sine squared is equal to 1. And usually that's it. Well, I mean, you could add 2 or 3 to your arsenal. So like cos A plus B, for example, and sine A plus B, you could use them. And then you can derive the others, right? Yeah. I mean, you know, I try to rederive them every time. This may take a minute or 2, but I think it's better to know this. Okay, again, any questions on this? Any question on the stuff we have done so far? So I assume it's good. I mean, I see faces saying yes, and I see faces confused. Any questions? Last call. Okay. Now, absolute convergence. the series itself converges, right? Agree or not? Yes. Okay. That's an important theorem. Okay, is the converse true? No. So if sigma n equal 1 to infinity converges, an, does it necessarily imply that the series of the absolute value converge? What's a nice counterexample for that? Minus?
Minus 1 over n.
Minus 1 over n diverges.
No.
That's right. So if you take minus 1 to the n over n, the series of, does the series converge? You remember this? What test did you use for this? Alternating series test, which we're going to see right now. Sigma n equal 1 to infinity converges. This one converges, but if you put the absolute values, it diverges. Very good. Now, if sigma n equal 1 to infinity, an converges, but okay, an diverges. What do we call the series? We say that is, did you use a word for this one? Conditionally convergent. Is conditionally, one n and two l's, right? Conditionally, two n's and two l's? One n and two l's, right? Conditionally. Okay, now this brings us to the alternating series test. I mean, I'll do it in the particular form, but of course, there are many other forms. I mean, you know. So let's, so alternating series test. So, did you do it in plural, or you just said like a minus 1 to the n times a n? Is that how you did it? So you just did it in this form here. Yeah, and then you can shift. You can put minus n to minus 1 here. It doesn't matter, right? Okay, so we'll just do it this way. And you assume that an is positive, right? Did you do this? Okay. So anyone can remind me what the alternating series test says? So you have an is positive, and you have the series minus 1 to the n times an. What does the alternating series test say? Alternating series test, what does it say? Yeah? Then? Then? Yeah, same. Yeah, then the series minus 1 to the n a n converges. Now, does it say anything about absolute or conditional? No. It doesn't tell you whether it's absolutely converges or not. Okay, alternating series test. So I'll use the formula I've used before. an be a positive. Let an be a positive sequence. I'm just going to see if you use the book. What I think the book has it in a different form. But that's okay. Let an be a positive sequence. Then, well, a positive sequence such that an is decreasing, eventually decreasing goes to words. Okay, I will not say that. Eventually decreasing goes to words. Then okay, let's do an example. Does this series converge or not? Minus 1 to the n over n squared. Does it converge or not? Why?
Because it's positive and decreasing.
You mean 1 over n squared. Okay, very good. That's an answer. What's a nicer way? What's another way to do it?
T-series.
Why is it a series?
No, absolutely. Converge
Very
absolutely.
good. And that's it. So we have to take the absolute value of this, right? Is absolutely convergent. Hence, convergence. Very good. So here, did I need the alternate series test? No. Now, for this one, does this series converge or diverge? Of course, here 1 over n squared is positive. I forgot. Oh well, you don't need this. Does this one? Does it converge or diverge?
Conditional conversion.
Converge? Conditionally. Very good. Converge is conditionally. Oh, very good. Do I need to justify or that's fine? Are we good? Do I need to justify? Do I need to justify why or just not your head if you want to justify? Okay, so let's justify that. 1 over n sequence. An equal 1 over n is positive and decreasing. This is obvious. And limit 1 over n. By the alternating series, guys, hey, by the alternating series test, alternating series test, what do we get? Then sigma over n converges. Now, does it absolutely converge? If I take the absolute value, does it converge? If I take the absolute value of the terms inside, do they converge? But divergence. So what's converges condition? Awesome. That's great. Okay. So the ratio test, did you see it for positive series or you saw it for all series? Just for positive series. You didn't check it for absolute convergence, basically. You did it for absolute. So you took the limit of the absolute value of an plus 1 over an. Okay, and you said that the series is absolutely convergent. Did you do something where you check the boundaries or the interval of convergence? You didn't do that. Okay, great. So now let's move on to the ratio test. And the root test as well, right? You took the absolute value. Okay. Ratio test, so let an be a sequence such that n is equal to 0. I don't think I will use the exact same. Yeah. Okay. If so what you took the limit. If the limit is did you consider the case where the limit is equal to infinity or not? Did you consider that? Because here it's so how did you see it? You said if the limit is strictly less than 1, then the series is absolutely convergent. That's what you saw.
And then if it's one, it's inclusive.
If 1 is inclusive, okay, and if it's bigger than 1,
Divergence.
okay, you saw this. Okay, very good. Okay. right? You've seen this? You have seen this? You have seen that this one diverges. So if this one diverges, yeah, have you seen this or not? We just saw this one. You show that both of them will diverge, right? Which one did you see? You saw both or not? Yeah, you saw this, right? Yeah? No? Yeah, so this might be a bit difficult to explain, but you didn't see this one. What did you see? So if L is bigger than 1, what did you see? If L is bigger than 1, what did you see?
We said that the divergence
It's referring to
of the ratio of an plus 1 over an
in absolute value.
is bigger than 1 absolute value, then it diverges.
Both of them diverges.
Um,
Both of them, right? It refers to what?
the limit. Oh, it as in, yeah, I don't know.
Okay. So both of them will diverge, okay? You've seen this?
Yes, sir.
Yes or no? If L right? The last one you saw as well, right? If n is equal to 1, the test is inconclusive. Okay? Record, you saw that these two diverge. Right? So it's neither conditionally convergent nor, it's neither convergent nor absolutely convergent. Okay. Because, the thing is that, oh, yeah, if n is bigger than 1, then it diverges. Right? This is always what you say, but it refers to what? Right? The absolute value for the an. But I think it's not very hard. Okay? I mean, I'm trying to read the argument of the book, see if I can explain it. That's okay. That's okay. Take it for granted. Okay? I'm pretty sure you have seen this. I'm pretty sure you have seen this. And you have proved this, right? You have seen that if L is bigger than 1, then the limit of the absolute value of an must be infinity, right? This is the way you do it. But, yeah. Example? Let's find examples. So I'll pick textbook examples actually. Let's pick nice and textbook examples. So let's see. Yeah. sequences were positive. So it didn't really matter if you had absolute value or not. Now, what we're gonna do maybe next lecture, for sure, is that we might consider things that are not positive. Okay? So yeah, so does this converge or diverge? Let's have a look. What can we apply here? The ratio test, right? Familiar or not? So let AN be okay, so AN is positive here. So what's AN plus 1 over AN? This is n plus 1 factorial times n plus 1 squared times En plus 1 over n factorial over n squared over En. Let's look at this. So I have n plus 1 factorial over n factorial. Sure. And then I have n squared e to the n. Okay, so what can I say about this limit? Can I simplify this? What's n plus 1 factorial over n factorial? This is n plus 1. N plus 1. En over En plus 1 is just 1 over e, right? And n squared over n plus 1 squared is just n. Okay. What is this? What is the limit of an over an plus 1? An plus 1 squared over an. What is that equal to? Where does n plus 1 go to? Infinity. 1 over e stays 1 over e. And n over n plus 1 squared, where does it go to? N over n plus 1 squared, where does it? Yeah, that's right, right? Did I make a mistake? It's good? Where does this thing go to? N plus 1 goes to where? Everybody, I know it's hard to stay focused for 2 hours. It's hard for me as well, but we should stay focused as much as possible. So where does n plus 1 go to? Infinity. Where does 1 over e go to? Where does n over n plus 1 squared go to? 1. So where does this thing go to? An plus 1 over an goes to infinity. So what can I say about the series? Divergence. Then an diverges. Let me see if I can find a nice example where it converges. Something interesting. Something very interesting. Let's see. Okay. Let's use this one. Wow. Wait. Okay. What do you suggest here? Always when you have a factorial, it's a good idea to think of the ratio test. Did you see this tip?
Yes.
It's a good idea. I'm not saying it's the only way or the obvious way or the easy way, but it's a good tip to have. It's a good trick to start. Okay, great. So we take the ratio test. How do we do that? What time is it? 1% at a time. Yes, what time?
125.
125. Oh, so we're done?
Yeah.
Oh, okay. Whoa, it's fast. angry. Unless you want me to finish this. Next time. Okay, great.